Hello everyone, hope that you're doing well. Today we're doing a CSEC physics past paper. This is a paper 1 and this paper was from January 2020. Now please remember, before you start the examination, you should read through the instructions carefully, and if you should have any questions or queries, please clarify those with the examiner before the examination begins. Now let's jump to question number 1. And question number 1 reads, which of the following instruments is suitable for measuring the diameter of a human hair? And that is a micrometer screw gauge. All right, it measures very thin objects. Now for question number 2, which is a repeat question, it states that 0.000462 newtons expressed in standard form is, and that answer is 4.62 times 10 to the negative 5. All you need to do is to move over the points until you reach your first significant figure. So we move 5 places, and so that's why it is a negative 5, because we're moving to the right. All right, so let's go into question number 3. And for question number 3, and this here, it said that the item 3 refers to the following measuring cylinder, which is used to determine the volume of a liquid. And so they're asking us here that the volume of the liquid in centimeters cube. And so what you need to do is to read at the bottom of the meniscus. And notice that the bottom of the meniscus is on this line that marked in red. And so it is just between 8 and 7. And so that is 7.5. So it's halfway through. And so 7.5 centimeters cube will be the volume of the liquid. All right, now for question number 4, which is up top of the paper. All right, so question number 4 now. It reads, in an experiment to locate the center of mass of a sheet of cardboard, a plumb line string, which is a string with a small mass on the end, is used. The plumb line is used too. And so the purpose for the plumb line when you're doing center of mass or center of gravity is to show which points are vertically below the pivot or the central point. All right, and so that's the purpose for using a plumb line. All right, and so question number 5. And item 5 refers to the following diagram, which shows a section of a thermometer. And I said, what is the reading shown on the thermometer? And the reading on the thermometer is 88 degrees Celsius. A point to note right here. If you notice, I'm going to show you this. If you count the number of increments between 80 and 90, because this is the point that you're going to read from right here, that I light in blue. And so if you notice, they have 1, 2, 3, 4, 5. All right. And so if you divide 10, which is from 80 to 90 is 10. So if you divide 10 by 5, you get 2. So each line represents 2 degrees. All right. And so this is definitely 88 degrees Celsius. All right. If it's a Celsius scale. All right. But that's 88 degrees. All right. So question number 6. It said, when standing on the moon, the mass of an astronaut is 70 kg. And this is also a repeat question. It said, when he returns to Earth, his approximate weight will be what? And so weight is equal to mass times gravity. And so therefore his weight going to be the mass, which is 70 kilograms, multiplied by 10, which is the gravitational force on the Earth. And so his weight will be 700 newtons on the Earth. A point to note that mass does not change, but weight change due to gravity. Question number 7. It said, which of the following is a derived unit? And as I look through here, meters cube is a derived unit because a combination of one or more of the basic units. And so we have here Kelvin, which used to measure temperature. We have S for seconds, and kg is for mass. And so therefore, meters cube, which is a volume, that definitely is a derived unit. All right, so next question here, and we're at question number 8. And the question states that an object of mass m is attached to a string balance and its weight w recorded. What will be the result if the object is taken to the moon, where the gravitational field strength is less, and weighed? All right, and so the answer here is that mass m will be less mass will equal to m because mass doesn't change. Just to make a note of that. So wherever you take it, the mass will still be the same mass as before. So that's why we say mass equal to m. But weight will be less than w because once you go on to the moon, the gravitational field is less. So it's going to be less than this weight at the original weight. Okay, so the mass remains the same. So the mass will be the same, but the weight will be different because it's on the moon where the gravitational field strength is less. All right, again, remember, mass remains, however, weight changes based upon the gravitational force acting on it. All right, for question number 9, it's a solid object X floats in mercury and sinks in water. All right, a solid object Y floats in both mercury and water. It said, which of the following statements is true about X and Y? All right, and so first we want to look at this, right, is that if X floats in mercury, it therefore means it is less dense than mercury. However, it sinks in water. That means X is more dense than water. All right, and then now we said that the solid Y, it floats in both. That means solid Y is less dense than both water and mercury. However, it's also less dense than Y as well, because again, X, we know that X is denser than water because it sinks in water. All right, and so definitely if Y if Y floats in both, then definitely Y must be less than an X. All right, so that is why B is the answer. X is more dense than Y, or the statement could have been Y is less dense than X. Okay, but so B is the most appropriate answer in this case. All right, so question number 10. And question number 10 reads that a glass marble X moving with a speed of 6 meters per second collides head on with an identical stationary glass marble. And the key thing here is that they're identical, which means they have the same mass, all right? Just to make a mention of that. And then now we said, what is the speed of Y after collision, assuming that X is brought to rest? So if X is brought to rest, right? And the point to note here that momentum is conserved, all right? Because total momentum before collision must equal the total momentum after collision. But the key point here is that the marbles, they're identical, okay? Very important thing. And so if one is brought to rest, then the next one will move with the same velocity from the first, because that velocity multiplied by that identical mass will give you the same momentum. And hence, C is the correct answer. All right, and so let's go into question 11. And question 11 said, which of the following features must be present in a stable, well-designed racing car? And for it to be stable, the low center of gravity off the bat is absolutely true. If it's narrow and wheelbase, then definitely the center of gravity will not be that nice in terms of low. So therefore, we'll have instability with that. A long front, nah, because it must be proportional as best as possible as well. So the best answer there is A. Now for question number 12, and let's go up top for that one. Now, question number 12 now reads that when two bodies collide, momentum is conserved. So notice this actually confirms what we said earlier. It said this means that and just slide down to the options. So what is happening here is that the total momentum of bodies before impact equals to the total momentum of the bodies after impact. So this is the correct answer here. So momentum before collision equal to momentum after collision, which be the total momentum. That's very important to put the word total. All right, so definitely D is the correct answer. For question number 13, it said, which of the following expressions can be used to find the speed of an object? All right, and to find speed, definitely C is correct, which is distance traveled over time. B would be incorrect because B is used to find velocity. Displacement over time is velocity, not speed. They are two different things. Remember that velocity is a vector quantity and speed is a scalar quantity. All right, and so definitely C. Now for question number 14, is the pressure in a liquid can be calculated using the formula P, which is the pressure, equals to density times gravity times height. Is which of the following set of units will give the pressure in the SI unit. And so firstly, what you need to know is that the unit for each, you need to know the unit for density, and the unit for density in the SI unit is kilograms per meters cube, and then gravity will be newtons per kilograms, and then height will be in meters. And so therefore B is the correct answer for this question. Now question number 15. Question number 15 is on the next page. And question number 15 now reads that which of the following sources of energy are classified as renewable? And so pretty much right here, solar energy, wind energy, geothermal energy, they're all renewable. So D is the correct answer for number 15. And so let's jump into the next question, which is question number 16. It said that the heat capacity of a substance is defined as the amount of heat. And so let's just look at what the specific heat capacity, well, this is a heat capacity, not specific heat, but heat capacity. And so for heat capacity, it is the heat energy needed to raise the temperature of a substance by 1 degree. All right, and that's what the heat capacity is. All right, and so let's go to question number 17. All right, and question number 17, it said when a ball is thrown vertically upwards and reaches the maximum height, it has what? And a point to note that when we reach maximum height, it is momentarily at rest, which means it is not moving instantaneously. A very short pause in that movement. So there's no movement. And since there's no movement, there can't be any kinetic energy. All right? And so C is correct because it has a maximum height, which means you have maximum potential. Because remember, potential energy is based upon position, right? And kinetic energy is based upon motion. And at maximum height, maximum potential, and maximum height, no movement, momentarily at rest. Therefore, no kinetic energy because kinetic energy is based upon motion. All right, for question number 18, I think that one is on top of the page. Let's slide up real quick. Question number 18, absolutely. All right, so for question number 18 now, it said that item 18 refers to the following graph, which is based on an experiment on the change of phase. All right, and so I make some notation right here. We're going to go through each of them. And so you have temperature here and temperature, and then you notice that the graph is going down. That means temperature is decreasing. And once you see it going down in that sense, it means that it is cooling. So this is a cooling curve, right? And it cools with time. So decreasing temperature means it's cooling. All right, and so it's the graph shows that solidification started at Q. Okay, and so we make a notation right here that solidification started at Q. And it said during which of the stage is the substance in a liquid phase? And this is a giveaway. Because if Q is solid, then above the solid must be a liquid. Because when liquid cools, when a liquid cools, then it will turn into a solid. And so once solidification is finished, it turns into a solid. So from R to S will be a solid. All right, so that's a giveaway right there. All right, so right here now between P and Q, that is when it is a liquid. All right, P and Q, definitely liquid. All right, so they give us a free question right there. I would say that. All right, but it's nice though. All right, for question number 19, it said which of the following processes is most likely to account for the fact that pot handles are usually made of wood or plastic? And so this is conduction is the answer, right? Because again, wood and plastic, they are poor conductors of heat. And so therefore, it will prevent conduction of heat. All right, and so definitely A is the correct answer. All right, so now we'll go into question number 20. And question number 20 said to check the upper fixed point on a thermometer on a Celsius scale, the thermometer is placed in what? And notice the key term right there said that the upper fixed point. And once you're going to measure the upper fixed point on a degree Celsius scale, then it must be placed in something that is higher the boiling point. So you could place in steam above the boiling water at atmospheric pressure. All right, and that to give you the upper temperature on that thermometer. Now, for question number 21, And question number 21 reads that in the pressure law, which of the following statement is true? And I'm sure this is a repeat question. Very, very sure. And so the pressure law, just to make a note right here, so the pressure is proportional to temperature for a fixed amount, which means a fixed amount of mass, which is a fixed mass, right, of a gas at constant volume. So volume is constant, and so B is the correct answer right there. Again, I know this is a repeat question for sure. And question number 22, it said, who was responsible for arriving at the conclusion that measurement amounts of electrical and mechanical energy can be converted proportionate amount of heat energy? And that was by Joule. All right. And of course, if you a giveaway in this question as well is talk about the mechanical energy. Remember that Joule itself is the unit for energy. All right. So that again is also another giveaway for this question. Right. And again, remember you have electrical energy. So energy, electrical energy is also a form of energy. So energy, mechanical energy, whatever energy, it is measured in the joule. All right, so Joule was credited for that. All right, so the next question here, it is question number 23. And for question number 23 up top, all right, let me quickly slide up there. 23, I think I'm moving a little bit too fast. Right, so we're there. And for question number 23, it said a student carries out an experiment to determine the specific heat capacity, which is lowercase c, of a solid using the electrical method. Which of the following equations should be used? And again, they're using here the electrical method. And I want to point out something with the formula right here, right? The formula they normally use to find the C, its energy equals to mass times the specific heat capacity times the change of temperature. And so therefore you could make C be the subject of a formula by dividing the energy by mass and the change of temperature, right? So C is equal to energy divided by mass times change of temperature. Now what I want to point out now though, right, that energy, because since we talk about electrical energy can be calculated by IVT, which is the current times voltage times time. So we can replace E with IVT, okay? And so again, it'll be IVT divided by mass multiplied by change of temperature. So therefore, C is correct. IVT divided by mass multiplied by the change of temperature. So you can have here, as they have theta, theta can replace T as well, all right? So either you have T or theta. But of course, the most commonly used one for CSEC is the theta in terms of temperature. However, question number 24 is which of the following is not an example of evaporation? And D is the correct option. As you look at it, they say that a loaded copper wire wraps around a block of ice, gradually cuts through the ice. And the reason why the copper wire could cut through the ice is because the ice will melt where the copper wire is. All right, because the copper wire, of course, will transfer heat quickly to that section of the ice and cause it to melt. So that's melting, not evaporation. All right, so question number 25. Let's go down to that page. And for question number 25, now, the question reads now that item 25 refers to the following diagram, which shows water boiling at the top of a glass test tube, while a piece of ice wrapped in a gauze remain unmelted at the bottom. And this here is a repeat question. And so the answer for this is which of the following statement provides the reason for this occurrence? And the correct answer is that water is a poor conductor of heat, and that's why it works like that. I also explained in the previous paper I did, also because while water is evaporating at the top, it takes away heat from the test tube as well. So less heat will go down, more heat will move away from the test tube. All right, because evaporation takes away heat. All right, and it's a similar situation that when we sweat, our bodies also lose heat by sweating. All right, so when the sweat evaporates, it takes away heat from our bodies. All right, so 26, it said that the energy required to change the state of a substance was determined to be EH, all right? Is that if the mass of the substance was doubled, the new value of EH, which is energy, will be what? And this is also a repeat question, because based on the formula, all right, the energy is equal to the mass, all right, times specific capacity times change in temperature. So it therefore means, and again, the reason why I also use that formula is because we have change in state. And once you're using state and change, you must use a specific heat capacity. If there's no change in state, then you're going to use latent heat of fusion or latent heat of vaporization. So no, the formula to use up top is the same formula right here, that E is equal to MC change in temperature. And so energy is proportional to mass, all right? And so if you double the mass, then naturally you have to double the energy as well. All right, so that's why A is correct for 26. I have a question number 27 at the bottom of this page. Let me go in, zoom in a little bit. All right, so it said now item 27 refers to the following diagram, which illustrates a longitudinal wave train produced on a slinky. It said which of the following distances represents the wavelength of the vibration. And a point to note when you talk about wavelength, it must be two equal consecutive points along the path of the wave. And so to get a wavelength, we have three options. However, they only gave us one. And so based on what they have is C to E. Because C to E, they are consecutive points, right? And they're the same points, consecutive points. They're the same points. A to C is also a correct option as well. B to D is also another option that you could choose. All right. So once the points are equal and consecutive, then that's a wavelength. All right. Now let's go to the next question. Question number 28. It said which of the following electromagnetic waves has the shortest wavelength? And I gave you here in order of increase in wavelength, starting from gamma, all right, and X-ray, UV light, visible light, infrared, all right, and so going from G to R to radio wave will be the longest. So this asks for the shortest one, so it must be gamma. So you start with gamma first, right? So the shortest one. All right, and so C is the correct answer for 28. Now let's go to 29. And for question number 29, it said, in the following diagrams, X and Y represents two wave pulses superposing on each other to give a resultant R. And so it said, which diagram best illustrates the principle of superposition? And superposition is pretty much when the waves come together and create a larger wave. That's a basic way you could explain it. They come together and create a larger wave. So, point to note, if you look at A, they're not in phase, they go in opposite direction. So definitely if you come together, you're going to cancel out each other. So that's why A is incorrect. That should just be a straight line. And for B, the two phases of the wave or pulses, they are going the same direction, which means they're equivalent. And if they're in phase, then they're going to create a larger wave. All right? It's similar to C. You should have a larger wave there as well. Now, why C is incorrect, even though you have it going the same direction, going upwards, right? The reason why C is incorrect is because it should not be equal to what the two were. Since the two are pretty much, notice the size that they drew over here. So this here, let's kind of make a note of it. This that they drew here is pretty much the same thing as over that side. So for that reason, it is not correct. It should be larger. So notice the red line that I put there. The red line indicate now it should be at least this big, twice the size of this one that they have. All right. And so D now is correct because these two are out of phase. They're opposite, going opposite direction. And so they're out of phase. If they come together, then you should have a cancellation of the wave pulses. All right. So D is absolutely the correct answer. All right, and so let's jump now into the next question, which is question number 30, halfway through. It said, if sound, let me just get a zoom into this, because this paper, the printing is not that perfect. All right, so for question number 30, it said, if sound of different frequencies are played in succession, it said, in which of the following properties would a change be detected? And so again, point to note is different frequencies, right? And frequencies determine pitch. A frequency of a wave determines the pitch of it. All right? And again, amplitude determines the loudness of it. So A will be detected since the frequencies are different. All right? Now for question number 31, Question number 31. Let's start down a little bit. All right. 31 is said though, is that the note from a drum is louder when it is struck harder because the sound waves produce a greater what? And that is amplitude. Because remember now, if it's louder, then it's a higher amplitude. Amplitude determines loudness. Again, frequency determines pitch. All right, so let's go to the next question, which is question number 32. All right, so we're going to go to question number 32. And question number 32 is up side of the page. All right, and this question now states that which of the following are laws of refraction? All right, so which of the following are laws of refraction? And so sine I over sine R, which gives a constant. Yes, that obeys the law. Angle of incidence equal to angle of refraction. Not true, because that's not even possible. And the third one is that incident ray, the refracted ray, and the normal at the point of incidence all in the same plane. And definitely that is also the law. So 1 and 3, they are correct. All right. And so 1 and 3, correct version of this question. All right, so let's go into the next question, or question number 33. And question number 33 now states, which of the following equations regarding units of physical quantities is not correct? And it said not correct. And so I just put a little notation on this side that charge is equal to IT. All right. And so definitely A is a correct version because I, which is current, and T, which is seconds, and charge columns definitely equals to IT. All right. Again, V is equal to IR. So definitely V is equal to current times resistance. So definitely that is a correct version right here. Energy is equal to the charge multiplied by voltage. Definitely so. Yes, that is also absolutely correct. Power now is equal to voltage times the charge, which is not true. And so if you notice here now, a version of this could have been, if you have current and voltage equals to power, then that could work. And you have different things like V square and R. Relationship between V square and R will also give you power. So definitely D is the incorrect one. All right. Now for 34, it said a ray of light leaves air and enters glass of refractive index 1.6. It said the angle of refraction is 27 degrees. All right. And now it said that now what is the sign of the angle of incidence? And so a point to note here is that N, which is the refractive index, equal to sine I over sine R. All right. And so by finding, it said that what is the sign of the angle of incidence, which is finding sine I. So what you're going to do to find sine I, you have to multiply N by sine R. All right. And so that's why we have here now 1.6, which is refractive index based on the question, multiplied by sine 27, right? All right. So C is the correct answer for that. And now we're going into question number 35. And for question number 35 is the item 35 refers to the following table, which lists the refractive indices of 4 different materials. And so we have air, ice, perspex, and diamond. And we have 1.0, 1.3, 1.5, and 2.4. Matter of fact, they're increasing in terms of refractive index. It's in which material would the light waves have the slowest speed? And a point to note, the greater the refractive index, the slower the light will move. And so therefore diamond will experience the slowest movement of light. All right. And so the greater the refractive index, which means more effect on the bending or refraction of the light itself. So more refraction simply means that you have more bending. And so more also means that you have more opposition to the movement or passage of light. All right, so next question, question number 36. And question number 36 is item 36 refers to the following diagram. And so I just make a notation. Before I go to the notation, let's talk about the questions to understand why I have those up there. All right, it said, what is the output at C and D when input of 0, 0 is made at A and B? So if A and B are 0, 0, first thing that we identify the type of logic gates that we have, right? And so we have AND, we have 2 AND, and we have a OR. And remember, for the output to be on for AND, that means both inputs must be on or 1, okay? So that's how AND work. AND, remember, U AND. So both must be on for the output to be on. Or means that either or, anyone could be on and the output will be on. All right? And so the or mean whichever one. There's no preference, you are, doesn't matter. All right. So if they say A and B are 0, therefore C must also be 0. Reason being, again, is the and. So the only way C could be 1, both A and B must be on. All right, and so if C is 0, right, motherfucker, we don't have to care about anything going to the last and, because there's no, we're going to talk about the output at and. I could talk about that, but let me just talk about D first. So if A is 0, right, if A is 0 and B is 0, this is a R. All right, so the bottom one is a R, right? So if this is R and A is 0 coming down and B is 0 coming down, if both of them are 0, then D must also be 0. Because for D to be 1, either A or B must be 1, right? And naturally, the last end right here, they didn't ask us for that, but the last end here must be 0. Because the reason why it must be 0, because this is an AND gate, C and D must be on for this final output to be on. All right, so therefore, all of this will be off through the entire circuit. All right, and so here, option A is the correct answer. Both C and D will be 0. Number 37, it says, which of the following combinations of ammeter characteristic is correct? And ammeter is placed in series within a circuit. All right, ammeter is placed in a series in a circuit. Just to make mention of that, so either A or B is the correct answer, but the resistance must be low, because if the resistance is high, what's going to happen is going to oppose the flow of current, and an ammeter should not resist the flow of current, because if it resists the flow of current, then the measurement of current even going to the ammeter itself will not be accurate. Okay, so there must be a very low resistance of the ammeter itself. All right. All right, so let's go to question number 38, and I think it is the bottom of this page right here. All right, and so question number 38 now is reads that, all right, I need to put a zoom into this. Well, zoom in. All right, there we go. All right, the printing is not perfect, but the item 38 refers to the following graph showing the variation of alternating current with time. And so we have current with time, and it said the value of the current I at time t1. So we have I1 and t1 is called what? And so they're asking about the point right here. All right, let me just make a notation right there. So the point at that point right there that does put that blue thing, that's what they're asking about, and so that we call it the peak value, which is the highest value. Okay, so definitely D is the correct answer for that question. Now, going to question number 39, all right, it said, item 39 refers to the following graphs, which represents two alternating currents. And so, graph 1 versus graph 2, what is the difference on it? Before we even go to the question, make some notation here. If you notice the amplitude for both of them, they are the same. So notice the notation in blue, the amplitudes are the same. So pretty much it is like 2.5 because it's halfway 5 going up, right? All right, and so the amplitude are the same, so know that they have the same loudness, right? Now in terms of frequency, graph 1 has more frequency, have a higher frequency, I should say. Reason being, if you notice the amount of complete waves produced within a certain time, for example, look at 0.01 times 0.01 second, we have a complete, pretty much, we do have a complete cycle of a wave. So that's one wave produced right there. However, for graph 2, at the same time, 0.01, it is not even half wave. All right, even if you put a line through right here, it's going to be a little bit less than half wave. So therefore, it produces less waves per second, and so therefore, you have a low frequency for graph 2. All right, so the question now asks which of the following combinations correctly identifies these currents? All right, and so again, as we mentioned, it said here, current with greater frequency. And so the one with greater frequency here is 1. So graph 1 has a higher frequency, as we mentioned, more waves produced per second. And then now it said current with greater peak value, and none of them, because they both have the same amplitude, if you want to call it amplitude right here. So the peak value, which is on top, they are exactly the same, which is 2.5. All right. So both of them experience a 2.5 peak value. So definitely D is the correct answer. Now for question number 40. All right. Yeah, we're on 40. It said a glass rod is rubbed with a piece of silk, becomes positively charged. The glass rod became charged by. All right. And so if it becomes positive, if something becomes positive, it means it loses negative electrons, right? And so losing the negative particles, which are electrons, they become more positive. The same thing in reality, same thing in life. The more you give away those bad traits, those bad attributes of yours, then the more positive you become. If you steal people's things and you stop doing that, more blessing to you. You become a better person. So if you take on negative things, you become a more negative person. All right. So for you to become positive, you must lose the negative. All right. Question number 41. Is that which of the following diagrams represents the electric field existing between two oppositely charged point charges? And so if they're oppositely point charges, let me just get into this. Very important. This question is really, really important. And so A is correct for one basic reason. If you notice between B and, well, it can only be between B and A, but why A is correct and not B? Because the direction must come from the positive point towards the negative points. All right. If you think about conventional current, all right, it moves from the positive to the negative. All right. And so that's why A is the correct answer. Now let's go to question number 42. Now, for question number 42, it stated that a voltmeter has a very high resistance so that it can be placed in. And notice the difference here now with a voltmeter compared to a meter. A meter must have a low resistance because the current flows through the ammeter itself, because the ammeter is connected in series. But the voltmeter now is connected in parallel to the circuit, right? And so now the voltmeter, since it's in parallel, it must have a high resistance. Why? Because you do not want any current to flow. A matter of fact, minimum amount of current flowing through the voltmeter itself. Because since you're testing current, you're testing voltage with the voltmeter, and remember that voltage is a driving force behind current. And so if you should reduce the current, naturally you're going to get an incorrect reading for voltage. All right. And so again, the reason why I place one in series, which is the ammeter, and the voltmeter in parallel is simply because of the measurement of the quantity or the variable. And again, also the opposition or the easy passage of current. All right. And so because there's a relationship between current and voltage. So current is the movement of the electrons, while the voltage is the driving force behind the movement of the electrons. All right. All right. We can talk about that some more at another time or in a different exam, but I'll give you pieces as I go along. Now, 43 is that which of the following statements about insulators are true? And it said that all electrons are bound firmly to the atom in an insulator. Yes, because if once electrons can move freely, then it's a conductor. All right, and that's why electric current is about the flow of electrons. And now the second one is said, and in an insulator, many electrons can move freely. No, that is incorrect. That's a conductor's business. The third option now is that an insulator could be charged by rubbing. Absolutely. All right, like a piece of pencil, you could rub a pencil on a shirt or a pen, and you take up a piece of paper. If you know about that experiment, yeah. So definitely, option B is the correct version for this question here. All right, so let's go to the next question now, and this question is bringing us into question number 44. Now, question number 44, now it reads that item 44 refers to the following diagram, which shows a small negatively charged, I notice I make a note right there, small negatively charged dust particle, midway between two plates and observed with a microscope. So if it is negatively charged, naturally going to go towards the positive, right? Now, it states now that which of the following arrows correctly indicates the direction of the dust particle when the switch S is closed. So if the switch S is closed, which means you have positive, the one terminal will be positive. So we can just make a note that here will be positive. So this plate becomes positive because current can flow through it. Now, if you close the circuit, current flowing through it, and this top one will be negative. And again, if the dust particle here, if it is negative, you're going to move towards the positive. So you're going to go downwards, right? And so downwards should be our answer. Let's see if it's there. Absolutely. C. All right. So that's 44. Let's go to question number 45 now. And question number 45 reads, where you are, right, is for a simple AC generator. Which of the following graphs will be produced by two complete rotation of the armature? All right, and so here, let me show you what's going to happen is a two complete rotation. All right, and if you have two complete rotations, what you're going to simply have, you're going to have two cycles. All right, and so option D is correct. Yeah, two cycles of waves produced. All right, and so if you notice, C, you have 1, 2, 3 cycles produced. That's not correct. B is only one cycle of wave, and A is only a half cycle. All right, so definitely D is correct. Two rotations equal to two cycles. All right, for 46, is that which of the following relationships is correct for the combination, for the combined resistance, which is RT of resistors, R1, R2, and R3 connected in parallel. So you're not seeing it properly in terms of RT and RS and so on, but the first R is RT, then you have R1, R2, R3, so there are three resistors there in parallel. So 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3, so B is the correct answer. All right, and I know most of you will remember that formula anyhow. All right, so number 47. All right, we're coming close to the end, you know. Number 47 is the item 47 refers to the following circuit diagrams. All right, a matter of fact, this here, I want you to pay keen attention because this is a parallel circuit. Most students, when it's, well, I'm not going to say most, but some students, when they see this type of circuit, they quickly say this is a series circuit, and I could understand why. Because it appeared to be that they're in one path, but truthfully, they are not. Because what is important is the point of the connection of the current or the flow of current right here, right? So here, current going in and current coming out. So one could be positive, one be negative, right? All right, and so if we consider the flow of current from the positive to negative terminal, then we know that definitely on the right will be our positive, sorry, on our left will be positive, and on the right, our right, not the screen right, will be the negative, right? Now, for you to have a current flow, you must have a voltage. So the points that are circled in blue, those are the point of the connection of the power supply, whether it be a battery, whatever it is, they connect to those two ends, which means current can flow in two different directions, okay? And notice what is a giveaway to make sure that this is also a parallel circuit is this arrow and this arrow. So current coming in could go to the top or to the bottom. So this is a parallel circuit. Very important for you to know that, because it's not going to help us to calculate the stuff that they ask us to do. And so let's quickly look at what they ask us to find right here. It's using the information given in the circuit, in the circuit diagram, which pair of values I1 and I2 is correct. And so what I want to point out, let us do I'm going to run through the calculation real quick. Now, to find the total resistance in a parallel circuit, and notice there are two resistors here, a 2 ohm and a 4 ohm resistor in parallel, okay? So how do you find the total resistance? It is equal to the product over the sum. That's a shortcut way. Or you can just say 1 over RT is equal to 1 over 2 plus 1 over 4. You can do it as in that sense as well, which is also fine. And if you do it that way, you're going to get the exact value. A matter of fact, I will tell you, you're going to get the exact value that you should have. So definitely here now, you have 8 over 6 gives you 1.3333 continuing. And so the current that was given here is 6. So the current is 6 that go into each lamp. All right, and so we have 6 amperes going in. And so the voltage, to find the voltage is equal to IR. So the current that is supplied to the circuit, the current that's supplied to the circuit. Now, I'm going to tell you that in a parallel circuit, just to make a note right, in a parallel circuit, each component, if they're not identical, receives different current, but the same voltage. That's a parallel circuit, all right? But the total circuit, the total current going into the circuit is 6 amperes. Since you have two different resistors, then the current going to each will be different. And let me just give you this reasoning. If you know what a resistor is a device that opposes the flow of current, right? So the higher the resistance is the less current that flows through it. And so you can imagine that the 4 ohms must have less current flowing through it than a 2 ohms resistor, right? The higher the resistance, the less current flowing through it. So you can use that as a guide to know if your answer is wrong or right. However, the total current supplied to the circuit and leaving the circuit is 6 ampere. So therefore means the 6 ampere is shared between the 2 ohms and the 4 ohms. And again, if you add up the current for each, you get back 6. You must get 6. All right, so let's go back to this again now. So V is equal to IR. So the voltage in the circuit, because a voltage in a parallel circuit must remain the same. So the voltage in the circuit must equals to the total current, which is 6 ampere, and the total resistance, which is 1.33 continuing. And so therefore voltage is equal to 1.3333 times 6 gives you 8, roughly 8. All right, but when I use the exact value, I get 8. So I use that. And so 8 is the voltage going into the circuit. Now to calculate the current of each resistor, what you're going to do, you're going to use the voltage, which is 8, and you're going to divide it by the resistance. Again, you can use this formula. To find current I, it is voltage divided by resistance. And so here going to be voltage 8 divided by 2 gives you 4 amperes for I1. And for I2, it's going to be 8, which is the voltage, divided by 4, which is the resistance. And so get here 8 over 4 gives you 2 ampere. Again, this proves the point I'm saying that the lower the resistance, the higher the current. All right, the higher the resistance, the lower the current flowing through it. Higher resistance opposing, which means higher opposition to the flow of current. All right, so let's jump to the next question now. Question number 47. All right, so using the information, no, sorry, I'm jumping. This is 47, just answer. Yeah, so it's 4 and 2 respectively. So these are the options. So 48. Now, for question number 48, they said when an excessive current passes through a fuse, which of the following is the sequence of events? So once you have excess current flowing through any fuse, the first thing happens is that the element of the fuse becomes hot. And once it becomes hot, it's going to melt. And once it melts, it will prevent current from flowing. So it breaks the circuit. So definitely B is correct. All right. All right. So next question now, 49. And 49 is on the top of the page. I think so. Yeah, 49 is on top up here. Now, so which of the following diagrams show the magnetic field between a bar magnet and a piece of iron? All right. And so again, I make some notation right here. For the first one, looks good. But what is happening right here is that the field lines should move into south. So move from north into south. So notice the field line, the arrows are going from south into the iron. That's not how magnets work. The south receives the field line, the north pushes them out. And so C is correct because the field lines are moving into S. All right, opposing to A. All right, definitely B. No. That's showing repulsion. D is also wrong. All right, so let's go to the next question now, which is question number, I think this is 50. Yep, question number 50. Is that which of the following diagrams represents the current/potential difference relationship for a metallic conductor at a constant temperature? And again, this is a repeat question, and so we know that this refers to Ohm's law. And Ohm's law states that the current flowing through a conductor is proportional to the voltage across it. And so if you're looking for proportionality between I and V, then the only graphs that show proportionality is B. A can be easily misled because even though the line comes through this, however, it is showing really an inverse relationship, meaning it's declining. As one increase, next one is declining. So it's not correct. All right, and so yes, B is the correct option for number 50. 51, It's a device which converts sound into electricity is called what? All right, and so I'm gonna put the answer for this one. But if it converts sound into electricity, what possibly converts sound into electricity? Think about it. A loudspeaker, a microphone, and definitely a microphone is the correct answer, because if you think about it, when you talk, all right, it will cause a vibration in a speaker, like a small speaker, which is a coil, wrapped around a magnet. So definitely a microphone will be your answer. Convert sound into electricity, certainly. All right, a speaker is the opposite way. Speaker now will take the electricity and convert it into sound. So it's opposite to a microphone. All right, the amplifier only amplifies the sound through the electrical signals, right? All right, and so D is totally out. All right, so let's go to the next question, which is 52. All right, so 52 is that which of the following circuits are electrically the same as the circuit above? And so this is circuit. Okay, so I never read that part, but that's fine. We have the circuit right here, which is a series circuit. So now you see this is a series circuit now. And we know this is a series circuit because both of them are connected together and they're coming from one source, which I circle right there. That's the battery. Well, technically it's a cell shown right now, not a battery, because it must have more than one cells to give a battery. All right, so things like that you need to know as well, right? So what is happening here? Since the series circuit, looking for a series circuit, right? So which of the following is the same as what is above? We have two lamps, one cell. The first one here, A, is a parallel circuit, if you notice it. B is also a parallel circuit. If you notice it, just kind of draw a little bit funny. All right, but it's a parallel circuit indeed. And C is a series circuit, just as the one that's shown above. All right, and D is also a parallel circuit. All right, so 53. It said magnetic induction occurs when what? All right, and so induction, there is no touching in induction. Just to make mention of that. So as an iron nail near a magnet becomes magnetized, and so B is the correct answer. You bring it near to it and becomes magnetized. Yes, so it's without touching at all. So if you look at AC, a magnet is suspended and points in the north-south direction. No, that's not induction. All right, and the rest are incorrect. So you can also pause and go through it, and you will see. All right, so let's go to 54 at this time, and we're kind of wrapping up to go to the end. Now, for 54, it said isotopes of an element differs from each other in that they have different what, and that means different number of neutrons. Remember that what defines an isotope. Isotopes are the same elements, right? Same elements, but they have different mass numbers because of difference in the number of neutrons, and that's very important. Number 55 is that which of the following graphs show how the activity of a radioactive source varies with time? This is also a repeat question. I remember this question vividly. And so D is the correct answer. That's a half-life graph. All right. And so definitely. The next question, which is question number 56. And it said, according to Rutherford Bohr model of a neutral stable atom, if N equals the number of neutrons, P equals number of protons, and E equals number of electrons in the atom, then for all elements, before I even go to the answer, let me just point out something. P, which is the proton number, it equals to the number of electrons and also equal to the atomic number. So those three things are equal. Atomic number equals the number of electrons, equal number of protons. Now the mass number equals to proton plus neutron. So therefore the neutron number is equal to mass minus proton. All right, so once you make a note of that. So for all elements, the proton must equal to the electron. So B is correct. N equals to E, never. Okay, they're not equal for a stable atom. That is, they're not the same. All right, and C, it said N plus E equal to P. Matter of fact, let's not even go through it. B is correct. Protons equals the number of electrons, which is the same thing as atomic number for a natural occurring element. All right, 57. So which of the following symbols would be possible for an isotope of a nuclide representing by A, Z, and X? So the element is X, A up top, and Z at the bottom. A represents the mass number, Z represents the proton number, right? Just to make mention. And so what I want you to remember about isotopes, the notation in red is that isotopes, the mass is different because the neutron is different. So the mass is different because of difference in neutron. And so the proton remains unchanged. You do not change a proton, because if you change a proton, then it's not an isotope. It becomes different element. And remember, the isotopes, they are the same elements, but different mass number because difference in neutron. And so if we look through all the options here, the only one that has the same Z is option D. It doesn't matter what to do with the mass, really, to be honest with you. Whether you want to add or minus from it, that really doesn't matter, because the fact that the mass number can be different, however, the proton number must remain the same. That's how you define isotopes. All right, so one isotope can differ from the next by either addition or a minus. However, though, from the natural occurring element, it normally add masses. All right, at least add a number to it. All right, just a point that out to understand the concept of isotope. Now, for 58, an isotope of uranium, which is 234, and when I say 234, I mean that's the mass number. So normally when you see an isotope and they refer to a number, that's the mass number that they refer to naturally. All right, so it is 238 uranium, and the proton number there is 92. It changes to thorium, which is 230, 90. Now, this is an example of what? And so what I want to point out here is that if the mass number decreases by 4, because that goes to 230, right? So whatever the particle is, the mass number must be 4. And the proton number decreases from 92 to 90. That means the proton number is 2. So you have 4 as the mass number, 2 as the proton number, and that defines our alpha particle. So it's an alpha decay. And so I drew the equation right here for you to understand it. So uranium was 234, the proton number is 92. It forms 230 thorium, and the proton number is 90. So remember what I said in the previous review is that the products, the masses on the product must equal to the masses on the reactant side. So whatever in front of the arrow must equal to what is behind the arrow or after the arrow. So 230 plus 4 must give you 234. 90 plus 2 must gives 92. All right? So that's that for that question. Now let's go to our final 2 questions. And so question number 59 is a sodium 24, and this is what I was talking about. So sodium 24 means 24 is the mass number, right? Decays into magnesium 24. So 24 again is the mass number for magnesium with the emission of a beta particle, and can be represented by the following equation. Notice this, a beta particle was emitted. All right, so what I want you to understand here in this question, you will see sodium here, which is 24. The proton number for sodium is 11. It gives magnesium, which is the mass number, 24, but the proton number is 12. So because they have the same mass number, but different proton number, they are different elements, yes? So different elements can have the same mass number if they are isotopes. All right, and so the product side right here, if there's no change in mass, then the mass of that particle must be 0. If the proton number increases by 1, what can you do with 12 to make it back 11 is to minus 1 from it, right? So this number here must be a minus 1. So 12 plus minus 1 gives 11. All right, and so we know that this particle A is the correct particle that should be here. It is a beta particle anyhow. So once you know the beta particle, you are good to go. Now, final question. And this question states, which of the following statements about radioisotopes is true? All right, and so reading through the options, the correct answer right here is that they are sometimes used in medicines. All right, so they're used in medicines and for different purpose as well. All right, and so I want to thank you for being here. Thank you for your sacrifice that you're making to do well on the examinations. And again, as always, I wish you luck on the examination. And if you haven't done so, please subscribe. And also share with your friends. Invite them to come over to watch some lessons and get some good grades. All right, so good luck. Talk to you soon. Take care, all right?